Hello friends, hearty welcome back to our online teaching session. Today we are going to start with new chapter of Science 1, that is effects of electric current. In the previous standard you learn about the static electricity. When glass rod is rubbed on silk cloth, rod gets positively charged. Similarly, when ebonite rod is rubbed on woolen cloth, the cloth gets the negative charge. Now, the question is that why does material gets negative charge? See, if you learn about the structure of atom, in the atom, at the center, in the nucleus, protons and neutrons are present. Protons are positively charged and neutrons are chargeless. While electrons, which are revolving around the nucleus, they are negatively charged. Means we can say that here electrons are only moving. Now, when we rub the two materials against each other, the electrons of one material transfer to the other materials. The material which receive electrons get negatively charged and the material which loses electrons gets positively charged. So, in the above case, the glass rod gets positively charged as the electrons from the glass rod is transferred on silk cloth. So in this way we can say that there is a static electricity, that charges are available for short time. Now after studying this static electricity in the previous standard, even you learn about the electric current, potential difference and Ohm's law in the ninth standard. Today we are going to revise about these three topics one. So before starting that topics one, you have to remember that in this chapter we are going to study about electric current flowing through a conducting wire, secondly electric current flowing through a resistor, third electromagnetic induction, and fourth electric motor, and fifth electric generator. These 5 points we are going to study in this chapter. So let us start with the basic things, that is the electric current, potential difference and Ohm's law. So you can see on the screen there is a wire, cylindrical wire shown on the, we can say, figure. So in the first figure, that is A figure, you can see the electrons are shown, they are moving in random direction. So here electrons are moving but they are in a random direction. Their speed is very less. Now when this wire is connected to the cell, then this electron starts moving from one end to another. This flow of electron is called as electric current. So when we say about electric current, we can say the flow of electron from one point to another is called electric current. Quantitatively, we can define electric current as the charge per unit time. So we can say electric current is equals to charge upon time. So electric current is equals to, we can say, I equals to Q upon T. Now this Q, it is measured in coulomb, its SI unit is coulomb and time in second. So the SI unit of the electric current is, we can say, coulomb per second. That is the new SI unit is given, that is, we can say, the ampere. The ampere, the name of scientist, in the honor of scientist Ampere, the SI unit of electric current is named as ampere. Now the second point about the potential difference. Now in the previous figure, again you can come back to the previous figure, you can see there is a wire connected to the cell. The cell has positive and negative ends. This positive means we can say high potential and negative means we can say low potential. So when we say there is a difference between this high and low, this difference is there, this difference is called as a potential difference. But we can define potential difference as the work done which is carried to unit positive charge from one point to another. So when the unit charge is carried from one point to another, whatever work is done, that work is called as a potential difference. So potential difference is equals to work done upon total charge transfer. So V is equals to W upon Q. After studying this, we can say potential difference. Now the SI unit of the potential difference is, we can say, it is the volt. It is given in the honor of scientist Alessandra Volta. Now after studying this one about the potential difference, let us study about the Ohm's law. Now this Ohm's law, it gives the relation between the potential difference and electric current. Let us see the statement. So long as the physical state of conductor remains same, the current flowing through the conductor is directly proportional to the potential difference between two ends. It means if you have taken one wire, and that wire, after passing the current, even if you pass the more voltage, if you apply more voltage one, the wire should not melt, its density should not change, its color should not be, we can say, change. So such called physical state. Physical state means their physical property should not be changed. So when this wire is there, if you apply more potential difference, the more current is obtained in the wire. It means voltage and the current are proportional to each other. So mathematically we can say Ohm's law, V is equals to IR. Now where R is called as a resistance. Now resistance means we can say that the obstruction. Now see, in the previous figure you have seen that the electrons are moving from the one end to the another end. So when they move from one end to another end, that time they collide with one another. Electrons collide with one another. Also they collide with the metal cations. So when they collide, their flow gets obstructed by this, we say, collision. So this obstruction by the collision of the electrons with each other, also with the metal cation, is called as a resistance. So this resistance, its SI unit is ohm. Ohm is given to the honor, we can say, the George Simon Ohm, the scientist George Simon Ohm. In the honor of this scientist, the SI unit of resistance is ohm. Now after studying this common terms, now see on the page number 47, there is a one diagram, it is a one picture is shown. In that picture there are three images are there, that is A, B and C. And in the ABC, this figure one, this image one, they ask some questions on this, we can say, they ask the discuss and observe and discuss that picture one. In that picture there are three images are there. In the image A, we observe that there is a two lamps are shown, there is a one TV, also there is, we can say, computer. In the image B, we can see the blades of fans are rotating, means we can say the blade, that fan is working on. In the C figure there is a, we can say that the electric bell is shown. Now they ask the question, what are the electric effects in that images one. In the first image, we can see that there is a in that the lamps are there, and lamps, that's why what happened, we get here the heating effect. You can see that the bulbs get heated one, so it is a heating effect of electric current. Also it produces light, we can say it is a production of light. Even TV, or we can say computer, it also shows the flash of light, means they also produces the light. If you come to the B image, there we can see that the blades of fans are rotating. It means we can say that the electric energy is converted into mechanical energy. In the third image, we have seen that there is a, we can say, electric bell. Here electricity is there converted into mechanical energy, and again this mechanical energy is there, it is converted into sound energy. After studying that, we can say that these images one, the observing and after discussions one, now just revise all that videos one. After videos, then just write the answers of the this given questions one. The questions are displayed on the screen one. Note down those questions one and write in the notebook one. Okay, thank you.